Very good morning, students. Welcome to our IIT and NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 7th students of Jogipeta branch, Indresham branch, and Varasiguda branch so far for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 7th. Our ongoing chapter, heat, and we are entering into the session number 2. Yesterday we started this chapter and we discussed about the few concepts of heat and temperature in the last class, right? In last class we discussed about the heat and temperature. We know that heat is the cause and temperature is the effect. Means when there is no heat, no temperature. When there is no temperature, no heat. So they are cause and effect, just like force and motion. So in mechanics, force is a cause, whereas motion is the effect. Right? Without force, there is no motion. If there is no motion, there is no force. Similarly, in the chapter heat also, heat plays very important role to either increase or decrease the temperature. That is the reason because we are saying that heat is a cause and temperature is an effect. So we know we measure the heat in calorie, right? Calorie is the unit, or you can write in joule or erg because it's a form of energy. Okay, where you see one calorie is equal to 4.18 or 4.2 joule. Whereas temperature, we can measure in Celsius or we can measure in the Kelvin, right? So these, and we have seen the difference also between the heat and temperature in the table form. So both are the mutually convertible terms, or one is cause, other is the effect. One is measured in calorie, other is measured in the Kelvin or joule or Celsius or erg or Fahrenheit. Okay, so by that we are clear that what is exactly what we learned in the last session, first session. Then today we are going to learn more and more about the heat. That is, what are the sources of heat? What is the effect of heat? Right? And what is the various scales of thermometer? Because yesterday we introduced the thermometer also. Different scales of thermometer. And what is the relation between them? We can get some numericals. Okay. All these things we cover in the today's session. Right? So good to see more number are added. Alwal KTS, Udimal Kapur, Palaknama, Varasiguda. Okay. So this is what we learn. Introduction about the heat and introduction about the temperature. Then we discuss, we have seen some scientist names who are responsible for designing the thermometers. To measure the temperature, we need thermometer. There are various types of thermometers I discussed with you. One is clinical thermometer. One is laboratory thermometer. Clinical thermometer starts from 0 to some around 35 degrees to 42 degrees. Whereas laboratory thermometer starts from -10 degrees to 110 degrees. So like that different, even 6 maximum minimum thermometer is one of them decided by the, you can see the great scientist on the screen. Okay. So Fahrenheit is there, Kelvin is there, Lord Kelvin, who is responsible for the designing of thermometer. So that is about the measurement of device. For the temperature is thermometer. Thermometer contains the some minimum value to maximum value. The minimum value is called lower fixed point. Maximum value is called upper fixed point. The difference between these two is called range. Range of the thermometer. Okay. That all we discussed in the last class. That is about heat and temperature, right? So when we are discussing about heat, compulsory we are discussing about temperature because temperature is the effect of the heat. Now you can see some colorful pictures here. All are familiar with you. Nothing is new. But all these are having some common point. That is, they are the sources of heat. What they are? They are sources what gives out heat. For example, first you see number one, sun. Sun is the natural source of the heat. Everybody know, right? So with sunlight, you can do so much work. The heat produced by sun, you can do a lot of works that commonly you know. So that is a natural source. The natural source of the heat is our, or you can say maximum, that is the peak level. Peak level heat is produced by sun. See, one logic I will tell, one important fact. If you can store solar energy produced by sun in one day, if you can store all the energy which is reaching the earth, with that energy, we can run the world for 1 year. So try to understand my statement. If you can store solar energy produced by sun in one day, with that energy, we can run entire world for 1 year without using any artificial petrol, diesel and all. But thing is, we have no source to store the energies. Even though there are solar panels are there and all there, we cannot store all the energy. Remaining energy is wasted and converted into other form. That much powerful. What I mean to say is, solar energy is the most powerful energy in the universe. But thing is, we cannot able to store it. See, in Japan, they are having more ways to store the energy. That is the reason they are running the automobiles also with solar cars. Solar cars are running in the Japan. They are using the solar energy stored by them into another purpose. But we are depending mainly on the other sources apart from solar energy. For example, we are depending on petrol, diesel. When diesel costs more in the Dubai countries and all, will be affected. So that is the reason day by day we can see the rise in the values of petrol and diesel. But really, if you want to reduce the pollution, if you want to reduce the cost, the solar energy is the best form of energy, best form of heating energy. Apart from that, apart from the solar energy, is the natural form of energy. There are some more energies are there, you can see on the picture. So candle is one form of, candle also can produce the heat. Correct or not? Candle. Of course, oven is the produce the heat, and table lamp produce the heat, iron box produce the heat, kettle produce the heat. Even electricity also, some cases electricity. Electricity is producing the heat, converting into heat energy. Electrical energy is converting into heat energy in case of oven, or in case of lamp, in case of iron box. Means not only these are sources, petrol is a source, diesel is a source, charcoal, coal is a source. Right? Coal also source of energy, wood also source of energy. These all comes as a source of energy where you can get the heat energy. By heating them, you can get by burning them, you can get the heat energy. So when petrol is burned, that heat energy is produced and converted into mechanical. That is the reason we can able to travel, we can able to move from one place to another place. Same in the case of diesel also. So we are producing the heat energy by using electricity also. So electrical energy can be converted into heat energy in the ovens or in iron box or lamps. Right? So many ways, so many sources are there to produce the heat. Even when you burn the wood, it will convert into heat energy. Coal convert into heat energy. What we are doing with that? We are doing some work. We are not simply wasting, we are doing some work. So that is the reason heat is said to be an energy. Because we are doing work with heat. With solar energy, you can do so much work. Not only we, even plants also, by the photosynthesis process, they can prepare their own food. We are also using the solar energy for so many purposes. If it is not sufficient, it's not sufficient for us, so we are going for the other alternate sources like wood, coal, petrol, diesel. All these things we are depending on. Even we can produce the heat energy from the friction also. Rubbing. Suppose we rub two hands, what happens? When you rub two hands, you can produce the heat. That is also heat energy. When you buy rubbing two stones in olden days, ancient days, they used to produce the fire by using the two stones only. That is also heat energy. There are so many ways, means so many sources, so many energies can be converted into heat also. Not only are directly getting the heat, we can convert the other energies into heat. Mechanical energy into heat, electrical energy into heat. Right? Like that, you can have so many innumerable number of sources to produce the heat. It may be by friction, it may be by wood, it may be by coal, it may be petrol or diesel, or electric energy, or oven, candle, lamps, iron, kettle, or even sun. All these are the major sources of heat. But among all these, the highest source of heat is sun only. Sun is the only source which can give the huge amount of heat, which we cannot able to use properly. Even less pollution also. Suppose when you burn the wood, when you burn the coal, when you burn petrol, diesel, kerosene, these are called the fuels, right? Which gives the heat energy. They are called fuels. These fuels will produce so much pollution in the atmosphere also. But solar energy cannot produce any pollution. So, sources are nothing but from where we are getting the heat. These are called sources. From where we are getting heat. Sources. Right? So, these are the so many sources where from where you can get the heat are. You can see the pictures, you can get the, you can note down also. Right? Sources of heat. Number one, sun. Number two, candle, oven, bulb, iron, kettle, friction, wood, coal, right? Petrol, diesel, even electricity also one of the source of heat. You can note down as this points, right? Point number one. For today, everything you can note. Just write the names, no need to draw the diagrams. Okay. The major natural and artificial. Natural source of heat is sun only. Right, sun. Remaining all comes under artificial source. Natural source, sun. And all these are the artificial source which are shown here and written here. So these wood, coal, petrol, diesel are called fuels because fuel is the one which burns in air and gives out the heat. The burns in air is called combustion. You might have learned in your chemistry, right? Done. Please note down that natural source is sun, artificial source are many. So after knowing what are the source, means till now we discussed about what is heat, what is temperature, right? Then what are the source of heat? From where we can get the heat? We know many more are there. These are the few examples here. There are so many industries, they are producing the heat. For example, take NTPC, Natural Thermal Power Station, where the heat is produced and that is converted into electricity also. Not only electricity is converted into heat, heat can be converted into electricity. Heat can be converted into mechanical energy. Heat can be converted into other form also. Like that, you can use the heat for many purposes. What is the petrol? Nothing but when you are using the petrol in a vehicle, it is converted into heat first. That heat energy makes the vehicle to move, and some of the heat energy may be wasted. So there is a conversion of energy, but there is no loss of energy as per the law of conservation of energy. So hope you all understood exactly what is the meaning of source. The source of heat is the way from where heat is produced, or way from where we can get the heat. All these are the examples for that. Okay? Right. Clear? So you can see the colorful pictures of the sources. Now we move to the next part. What are the effect of heat? effect. What happens when you supply heat to something? It's called effect of heat. Just you have seen effect of force also. When you apply force, what happens? Size changes, shape changes, direction changes, or speed changes. Similarly, heat also has its own effect. When any body, whether it is solid, liquid, or gas, when they are heated, what happens? That is called heat effects. Heat has the following effects. You can note afterwards. End of the day. Number one, increases the temperature. Agree or not? We already seen. When the body is heated, its temperature increases. So, example, as the heat increases, the temperature also increases. Very important point is given. And suppose you can take it as a third, already 2 points we wrote. Fourth, increases the volume, size. Right? Not only volume, everything. Length. So you can write even length, area also. Volume, length, area. All three will increase. Increase the volume, length, area. With increase of heat, the volume of the particular object also increases. In solids, liquids, and gases, the volume of the substances increases. When you are hitting the, suppose, when you hit the solid, any solid iron rod, automatically size increases. Or area increases. Size means only length. Lengthwise, breadthwise, height-wise. Increases, volume increases. You can heat any object. Expansion, that is called expansion of heat. Expansion of substance on heat. That is the important effect of the heat, that is increases the volume. So heat increases the temperature, heat increases the volume. Next one, brings about chemical change. In chemistry, when you see chemical changes, some chemical changes are takes place, which are permanent changes. We cannot get back them. So how the chemical change takes place? Due to supply of heat only. Whenever any two chemicals are added under the supply of heat, there is a new product is formed. Either two products may become one, or one product may become two. It may be composition reaction, decomposition reaction, substitute reaction. But we can find that there is a chemical change takes place. Right? See, the increase in the heat increases the rate of reaction and chemical reaction occurs. Rate of reaction means speed or slow, moderate. Three types of reactions are there. So it all happens because of the supply of heat. If you see any chemical reaction on arrow, we can find delta. The delta indicates supply of heat. Right? Under. Suppose CaCO3 is there. Calcium carbonate. When you supply the heat, it becomes CaO plus CO2. Why it is become new product? Because of the supply of heat. That is called chemical reaction. Some cases, the rate of reaction increases by supplying the heat. Means speed up. Reaction, suppose it may take 1 minute. When you supply the heat, it may take within 30 seconds. Because the speed increases by supplying the heat. That is called rate of reactions. Not only chemical change, also brings the physical change also. By supplying the heat, we can see that there is a physical change. So as increases physical state of the body, suppose a solid can be converted into liquid. See iron. How we are getting the iron in the particular shape? How this bottle got the shape? See, this is the water bottle is there, right? How this got its shape? Because after making the liquid, they heat the metal at high temperature, enormous temperature. Then it's converted into liquid that is poured into a desired shape. Whatever shape you want iron, either it is a plate or a bowl or a wheel, right, or a rim, anything. The shape we are getting because of the heating. After heating, we'll make them into cool. So even physically, some colors also changes. While heating the chemicals, the color of chemical also changes. So why color? That is nothing but physical change. So physical change means you can get it back again. Reversible. Chemical change is irreversible. So like that, when you are heating, These are the effects, right? So heating increases the temperature, increases the volume, length or area, brings the chemical change, also brings about physical change. These are the most important effects of heating an object, heating solid, liquid or gas, any state, right? You can note down the points first. Take 5 minutes to note down the points, then we'll move to the next part. Note down as a synopsis. So far, we discussed about source of heat and effect of heat. So there are 4 effects of heat are there, and there are many source of heats. Even you can take this as a project also. You can put on colorful chart, right? Source of heat, you can correct the pictures also. For source, you can get the colorful pictures and you can paste on chart and you can display in your classroom. You can make your classroom colorful and knowledgeable, right? So I request the teachers to motivate the students to do the activities in particular topics. You can show them what are the sources. They know everywhere. Anyway, they'll see in houses, but right. We'll move forward to know more about the heat and temperature. Okay. Now see. So thermometer. About thermometer, we already discussed, right? We discussed thermometer is a device used to measure the temperature. So depends on the requirement, which temperature we have to measure. There are different types of thermometers are there. So thermometer works on the principle of expansion of liquids, because in thermometer we use the mercury. When the mercury expands on raising the heat, automatically we record the temperature. But nowadays we are in the digital also. You can see, maybe having it in homes. Directly you can get the number. We cannot see any mercury or any constriction. Directly digital number based on the temperature. Either you keep under the armpit. You can directly record the temperature of human body. So human body temperature is measured by clinical thermometer. Clinical. Right. It may be mercury thermometer or it may be digital thermometer. Suppose in laboratory, when you want to do some experiments and you want to measure the temperature of the chemicals or chemical reactions, we can use the laboratory thermometer, which starts from -10 to 110 degrees Celsius. Totally 120 divisions are there. Right? That is called range. Then we have to measure the atmospheric pressure. Pressure in the atmosphere by meteorological station, weather reporting stations, weather forecasting stations. They'll use the 6 maximum and minimum thermometer. Nowadays, is also coming into the digital form only. Directly, anytime you can go and see what is the minimum temperature and what is the maximum temperature on the both sides of the U-shaped tube. You will learn in the regular syllabus. Okay. So we'll give the priority for the mercury to use because of some special properties. Mercury will have some special properties. Because of that, we are using the mercury in the thermometers. It looks visible, easily visible. It is shiny, and even temperature also, the different temperature it can raise. Right. Now the table is there at the bottom about the heat and temperature difference. We can see temperature and heat. Difference between the temperature and heat you can see here. First point, heat is the form of energy. Hence, it is a capacity for doing work. Temperature indicates their condition of body, which may be stated as how much hot or cold, how much cold of the body. That is degree of hotness or coldness. Heat is a cause. Temperature, I told you, very important point. Heat is the cause. Temperature is the effect. We can write this table from your material also. Then, two bodies of same substance having different masses may have same amount of heat but different temperature. Two bodies of same substance having different masses may have same temperature but different amount of heat. So depends on the material, whether it absorbs the heat more or less depends. It depends on some factors. There are some factors like mass, like temperature, change in temperature. Depends on that, the heat absorbed by body, right? Heat converts of the body do not decide the direction of the flow from the body. Temperature of the body decides the direction of the heat of flow. SI unit of heat is joule. The SI unit of temperature is Kelvin. Already we discussed it. Right. So heat, temperature, thermometer, effect of heat, source of heat. We are clear, right? The heat and temperature you can write in notebook also. So before going further, now just, temperature units are given there. Scales of thermometers, very, very important. Very, very important. Scales of thermometer. As per our requirement, where you want to use a thermometer, different scales are designed. There are 4 scales. So one is Celsius scale, or is also called centigrade scale. Right. Second one is Fahrenheit scale, and third one is Kelvin scale or absolute scale. Fourth one is Romer scale. So how they are different from each other? They are differ by their LFP and UFP. So lower fixed, for example, see, for first Celsius scale, 0 degrees to 100 degrees. So 0 is the lower fixed point. We can measure 0 degrees to 100 degrees by using the Celsius scale. When you come to the Fahrenheit scale, it is 32 degrees to 180 degrees. Sorry, 32 to 212. Just a minute. I'll write clearly. So each and every scale is classified or is identified by only their LFP and UFP. They are different from each other, right? They are differ by only lower fixed point and higher fixed point. So here you can see 0 to 100. And second one is 32 degrees to 212. There is minimum 32 Fahrenheit you can measure. Next, Kelvin. Minimum starts with 273 to 373. and Roemer 0 to 80. So each scale is distinguished or different from each other by lower fixed point and upper fixed point. So you can write here 0 is the lower fixed point, 100 is the upper fixed point of. Then what is the difference is called range. Means how many divisions do you have? So what is the 100 minus 0? 100. 100 is the range of the Celsius scale. 212 minus 32, 180. 180 is the range of the Fahrenheit scale. Means Fahrenheit scale contains 180 divisions, starting from 32, 33, 34, 35, 36, up to 212. Whereas Kelvin scale is having the 100, because 373 minus 273. It is having 80, 80 minus 0. So this is called range. Range means that thermometer contains those many divisions. Those many divisions. Right? LFP, UFP, range. Means each scale of temperature is classified based on their lower fixed point and upper fixed point. Clear? So the lower fixed point of the Celsius scale is 0 degrees Celsius. Upper fixed point is 100 degrees Celsius. It is contains 100 equal parts, 100 divisions, each of 1 degree. This 0, 1, 2, 3, 4, 5, 6 up to 100. Right? When you come to the Fahrenheit scale, this is devised by Fahrenheit, name of the scientist, in 1717, 1717 year. Okay, almost 500 years back. Then on this scale, the lower fixed point is 32 degrees Fahrenheit, upper fixed point is 212 degrees Fahrenheit. Kelvin scale is divided by Lord Kelvin. Right? It is 273 is the lower fixed point, 373 is the upper fixed point, which contains 100 equal divisions. Okay. Then Roemer scale, then 80 divisions starting from 0 to 80. It is now presently it is not that much use. It is out of this. Mainly we are using the 3 scales: Celsius, Fahrenheit, and Kelvin. Suppose you may ask, sir, some scales, suppose Celsius is given. Can we convert them into other scales? You get that out? To see newspapers, when they give the report, weather report, you may be seeing temperature of Hyderabad is 35 degrees Celsius and 98 degrees Fahrenheit, or 42 degrees and 112 degrees. Both they'll give. Means degrees and Fahrenheit they give. How they are getting? They are getting by some relation. There is a standard relationship between all the 4 scales of temperature. So all 4 scales of temperature having the standard relation. With that relation, we can convert the one scale into another scale. One scale into another. So Roemer is given here about Roemer. See the diagrams also given. 273 to 273, that is Kelvin. 0 to 100 Celsius. 32 to 200 Fahrenheit. 3 scales are given here. They are marked with each of 1 division. So table also given. How I explained, table is given, see here. So Celsius scale, lower fixed point is 0, upper fixed point is 100, range is 100, because range is nothing but UFP minus LFP. Same Fahrenheit, same Kelvin, same Roemer. Got it or not? So clearly they are mentioning the what is the lower fixed point, upper fixed point, and number of divisions of the fundamental interval. That is difference between UFP minus LFP. So there are 4 scales are there for the temperature: Celsius scale or centigrade scale, Fahrenheit scale. Third one is Kelvin scale or absolute scale, and the 4th one is Roemer scale. So Celsius scale having the lower fixed point of 0 degrees Celsius, upper fixed point of 100 degrees, and the range is 100 degrees, 100 minus 0. Fahrenheit scales, lower fixed point is 32 degrees Fahrenheit, upper fixed point is 212 degrees Fahrenheit, and range is 212 minus 32, 180. Kelvin scale, lower fixed point is 273 Kelvin, upper fixed point is 373 Kelvin. The range is 100. Roemer scale starts with 0 degrees Roemer and 80 degrees Roemer. The difference is 80. Right? Hope you are clear. Among these four, the relation. So there is a relationship between all the four thermometers. Right? That we'll discuss in the next class. What is the relation and problems related to the relation between them. There are so many problems also you can come across. Relation between the thermometers. You can convert one into another by using the formula. I'll give a standard equation as well as for the how to get that one. Okay. Okay. So here you can see the formula at the end. We'll discuss in the next class. Right. So today what we discussed is we reviewed what is heat and temperature. Right. We reviewed about that and thermometer. Then we started about what are the source and effects of heat, source of heat and effects of heat. Then we have seen the different scales of thermometers. Right. Of course, we have not discussed about the relation. You can see there on screen the relation between the thermometers. C/5. This is the final one. That how you'll get, I'll explain you. Last line, if you see, last in the dead bottom of the page, you can see. You can see here. This is a final relation. That is C/5 is equal to F minus 32/9 is equal to K minus 273/5 is equal to R/4. So where C is the Celsius, F is the Fahrenheit, K is the Kelvin, R is the Roemer. So by using this relation, you can solve so many problems. So how you got this equation, I will explain you in the next session, right? So that's all for today. So just write the homework as source and effects of heat. What are the, already you might have written, what are the source of heat, what are the effects of heat, right? So that's all for today. Thank you very much, students. Have a wonderful day. Thank you. Thank you, each and everyone.